Good morning, everyone. This is Dr. B.C. Patra from NRRI Cuttack. So we'll be waiting for 1-2 minutes more. The DG IMD has not yet joined. Some problem is there, so we'll wait for 2-3 minutes. Dr. Kuttu.
Yes, sir.
Yeah, you are there. I have seen. Yeah, please, we'll wait another 2-3 minutes.
Okay, sir.
Okay.
Good morning, everyone. So this is from NRI side. So we are sorry to say that we have to wait for another 2 to 5 minutes for a technical problem with the speaker. So once he joins, we will be immediately starting. Thank you for your patience.
So I talked to DG office now. I think he will take 1 more minute. So meanwhile, we'll welcome our honorable RSC members who have kindly joined this program, and also a few of our QRT members, quinquennial review team members. They have also joined. So we'll be welcoming each one of you. So I think we'll wait for 1 more minute, please. Please bear with us.
Sir.
Okay.
Namaskar, I have joined. Good morning.
Good morning, sir. Welcome and thank you for joining us. So, sir, let us start then.
Let me just say hello to him. Good morning, sir. It is Dipankar Maiti, Director NRI.
Good morning.
Welcome, sir. Welcome, sir. Please, Kutub.
Yeah.
Sir, namaste, sir. BC Patra here, sir.
Namaskar.
Sir.
Okay. Now the speaker has joined and we will be starting this meeting now. Good morning, everyone. Respected Dr. Dipankar Maiti, Director, National Rice Research Institute. Today's speaker, Dr. Mrityunjay Mohapatra, Director General of Meteorology, Indian Meteorological Department, all head of the divisions, scientists and personnel from NRI and other institutes, NRI, RAC and QRT members, ladies and gentlemen, a very good morning and warm welcome to NRI Foundation Day lecture. Now, as per the formality, I would brief you about the institute and the lecture series that you are attending today. As you know, if we could recollect the past, the disastrous year 1943, we witnessed the suffering from the Great Bengal famine. The famine caused around 2.5 million deaths due to starvation. One of the causes of the famine was identified as the devastating rice fungus that lead to serious scarcity of rice grain in the Bengal province. Government of India then realized the importance of rice in this area and decided to intensify research on all aspects of rice crop. As a result, government established the Central Rice Research Institute back on April 23, 1946. Dr. K. Ramaiah, who was an eminent rice breeder, was its founder director. The famous botanist, Dr. Pranakrishna Parija, Director of Agriculture, Odisha, and the Maharaja Krishna Chandra Gajapati, Prime Minister of Odisha, were another 2 architects behind the establishment of this great institute. CRRI has recently been renamed as National Rice Research Institute, abbreviated as NRI.
Foundation IMD DG
Since then, the Institute has been tirelessly working on all researchable aspects of rice crop and has made significant contributions towards enriching the rice science and ensuring food and nutritional security of the country. The seeds of Green Revolution were planted at the field of this institute and spread to the rest of the country as narrated by the father of Green Revolution, M.S. Swaminathan. Till now, the institute has released 140 rice varieties, developed numerous crop production and protection technologies, and continuously providing assistance to the rice farmers and other stakeholders. NRRI has a total of 5 different divisions: crop improvement divisions, crop production division, crop protection division, crop physiology and biochemistry division, and social science division. We also have 3 regional research stations located at 3 different states. And additionally, 2 Krishi Vigyan Kendras are also managed by NRRI. The first brick of this institute was laid in 1946, and we are completing 75 years of glorious presence this year, 2021. As part of the year-wide long celebrations, NRRI is organizing Platinum Jubilee Lecture Series. And today, the lecture has been ending. We are ending with the Foundation Day lecture. These lectures has been delivered by outstanding personalities of the country and abroad. So we are lucky to have with us today Dr. Mrityunjay Mohapatra, who is the Director General of Meteorology, Indian Meteorological Department, for this prestigious Foundation Day lecture. You know, in the era of climate change, weather is becoming more and more unpredictable. No doubt, agriculture is highly sensitive to weather. And Dr. Mohapatra would be talking about weather forecasting for agriculture, a very relevant topic to all of us, especially agricultural scientists. Not taking further time, sir, I would like to request Director NRRI, Dr. Dipankar Maiti, to preside over today's function. And I request Dr. B.C. Patra, Head Crop Improvement Division NRRI, to formally welcome and introduce the speaker to the audience.
Thank you, Dr. Kutub. Respected President Sir, our honorable guest, Dr. Mrityunjay Mohapatra, esteemed RSC members of this institute, directors from different ICAR institutes, scientists from different institutes, our scientists from our National Rice Institute, Cuttack, and other participants from different organizations. So I welcome one and all. I have the pleasure now to introduce our speaker. And as you know, Dr. Mrityunjay Mohapatra, he joined as Director General of Meteorology in Indian Meteorological Department on 1st August 2019. He is the permanent representative of India with World Meteorological Organization, and he was elected as member of Executive Council, WMO. He is basically a physics scientist. He had his PhD and then he worked on this meteorological department, and he has about 28 years of experience in meteorology. He has made significant contributions in improvement of cyclone warning services of IMD. He has brought laurels to the country from various international agencies like United Nations, World Meteorological Organization for effective cyclone warning. Dr. Mohapatra has significantly contributed at national and international levels towards the science of cyclone through research and development, improvement of cyclone prediction and warning services through application of developed scientific methods and technology, and serve the society by enabling the disaster managers and general public to minimize the loss of lives and properties due to cyclones in the region. To mention a few are the timely and accurate warnings for cyclones, especially this Philin in 2013, Hudhud in 2014, Varda in 2016, Titli, Sagar and Mekun in 2018, Fani and Bulbul in 2019, Amphan and Nisagra in 2020. His brilliance and expertise in cyclone warning has helped in better management of cyclones, limiting loss of human lives to double digit, not only in India, but also in other North Indian Ocean region countries. He is popularly known as the Cyclone Man of India. He has authored about several books, and he has, to his credit, he has 90 research papers in international journals, and he has also editing 7 journals. He has received a number of awards and recognitions, including He recently got Doctor of DSc from Fakir Mohan University, Baleswar, Odisha. He also got DSc from Kalinga Institute of Industrial Technology, Odisha, Bhubaneswar. He is the fellow of Indian Meteorological Society and Indian Climate Congress. And then he has been felicitated by our Honorable Chief Minister Naveen Patnaik, Chief Minister of Odisha, for his and received an appreciation certificate for saving this human loss and poverty in cyclone warning services. He received commendation certificate from Defense DRDO, Defense Research and Development Organization, for contribution in integrated guided missile development program in 1989. He has commendation appreciation certificate from different organizations from different years he has received for successful prediction of cyclone. And he has published and documentary videos on live profile and contribution to cyclone warning service in various press and electronic media. He is the chairman of various committees, including the task team for finalization of meteorological payloads of INSAT-4 satellites to be launched in 2025, and committee for revision of NDMA guidelines for cyclone management, technical evaluation committee for consultancy on national cyclone risk management, risk mitigation project of NDMA, Government of India. He is presently the president of Indian Meteorological Society, and he has several prizes, accolades, and credits to his credit. With this brief biography, I will once again request Dr. Mrityunjay Mohapatra and welcome him also, and I will welcome him to deliver the talk. And he will be speaking on the very relevant topic, which is very relevant to us, especially this rice scientists and agriculture scientists, on the topic weather forecasting for agriculture. Because the weather is this morning also, sir, in Cuttack also, the weather has completely changed. It has started it has started drizzling, sir. Sir, with this beautiful morning, I welcome you once again and leave the floor to you, sir. Thank you, sir. Please.
Namaskar, good morning to all of you. Dr. Maiti, Director of National Rice Research Institute, Cuttack. Dr. B.C. Patra, distinguished scientists of NRRI, scientists and engineers participating from other institutes and organizations, dear friends and colleagues. At the outset, I wish all of you a happy and healthy life. I wish all of you to stay safe and stay healthy in view of this threat due to COVID-19 and its second wave. I got delayed for about 5 minutes because of this purpose only. I was addressing to all my colleagues across the country in view of this threat, which is affecting the individual, affecting the institute, and all spans of the activities in the society. But however, I am happy that the scientific community has come up very well. And we in India Meteorology Department have also ensured ourselves to be safe and also to provide all our weather and climate services and their applications in various sectors without any disruptions. So through this, I congratulate you for your continuous support and fight against this COVID-19 and helping yourself and the entire society to be stronger and stronger and to come out of this pandemic. I am really very happy to be associated with this Foundation Day program of NRRI. I congratulate Director NRRI and all the members of NRRI family on this 75th Foundation Day, and I am privileged to be associated with your festive occasion and for being invited to deliver a lecture. As Dr. Patra was telling, weather and climate are part and parcel of all the activities in the society. But considering India as an agrarian country still, and still agriculture being a major contributor to our gross domestic product, weather forecasting has a special role in agriculture. And I'll try to bring out some of the facts and figures about the current status of weather forecasting in the field of agriculture, the gap areas, and the scope for further improvement. I'll request to bear with me for 1 minute so that I can share the presentation with all of you. Whether my slide is visible?
Yes, sir.
Okay. Is it moving? Are you finding
Yes,
the second
moving.
slide?
Can you put it on slideshow mode?
It is in slideshow.
Okay. It's
Yes,
moving.
sir. It is moving also.
Okay. So you are able to find the second slide, why Agronomic Advisory Services?
Yes.
Yes.
Okay. Thank you. So as I was telling that weather forecasting plays a dominant role in agriculture. It is because any variation in weather and climate will have major impact on agricultural output. The long-term agricultural productivity and food security is affected by ongoing climate variability. It is being told. All of us know there has been a climate change which has been manifested in terms of the occurrence of extreme weather with increased frequency and intensity. And we have seen the impact of this climate change on various sectors, especially the agriculture and food security and disaster management, even individual health and energy sector. We also see that as per the findings of IPCC and other international and national bodies, over the next 30 years, food production needs to be doubled in view of this climate change. And Government of India has also taken up a very ambitious program for doubling the farmers' income. The ability of the farmers to take decisions on farm operations needs to be enhanced with the advanced information on weather and climate related issues. Each and every crop practices with respect to different individual crops needs the technological intervention so that there can be minimization of the input costs by the farmers. There can be maximization of the resources through crop scheduling, crop phasing, and application of various practices like application of fertilizers, irrigations, pests, etc. And by that way, ensuring the maximization of the crop yield through minimizing the losses due to disasters and diseases. At the same time, the dissemination of the climate information and weather forecast along the farm management operations also is increasing over the years in the form of advisories to the individual farmers, farming community, and the scientists, engineers, managers, practitioners associated with the farming operations. But still there is scope to improve it further. The technology in the present day world is very dynamic. It is changing rapidly, and it has to be utilized at the individual farming level and also at the management level. So access to this dynamical technology, which is continuously being developed, and the weather sensitivity can help the individual farmers and also decision makers to have an improved decision. It can be an enabler. The technology can be an enabler to improve the decision making for weather sensitive operations in agriculture. So if you just look at, therefore, the needs of farmers or planners with respect to weather forecasting in agriculture, we see that the location-specific changes and variability in weather and climate is very much essential in this sector. We need forecasts for a few hours to short and medium range, extended range forecast, shape up to 1 week, 2 weeks, 3 weeks, or 4 weeks, and of course the seasonal forecast. Just like Patra was telling that from yesterday to today, there has been a significant improvement and development in terms of weather forecast. So you need that type of information which can be delivered within a few hours for immediate intervention by the farmers. Say, for example, if a farmer wants to go for applying the fertilizer, he has planned it for today for noon, and today morning we could be issuing a forecast telling that during next 3 hours there will be heavy downpour, then perhaps the farmer will not go for application of fertilizers. So by that way, the very short range forecast, which is called as nowcast, can also help to minimize the losses, to maximize the yield. If it is crop in the harvesting stage and you are expecting heavy rain, for example, you can guide the farmers to go for immediate harvesting and hence maximize the yield. So like that, there are various applications we will discuss through this presentation in short and medium range, that is from 1 day to up to 7 to 10 days, and extended range up to 4 weeks, and seasonal range for any particular period more than a month. As all of us know, the major losses to the farmers occur because of the multi-hazards, and especially the areas specific Odisha, if you consider, which is a multi-hazard state. And about 80% of all the hazards are weather related. So therefore, if we can provide this multi-hazard information early, accurately, and timely, then it can also help the individual farmers to maximize their yield and minimize the input cost and avoid the losses. The crop stresses based on disease conditions and their prognosis is also very much essential, and these are also needed by farmers and the planners. Weather and climate-based farm management, it has started long back, it has improved over the years, but still there are gaps which need to be addressed to have its full potential in the farm management. Personalized advisory for farmers. An individual farmer expects the information in his crop field, which may not be possible because of the limitations in technology. But however, there are ways and means by the way in which we can reach out to each and every farmer and have some kind of personalized advisories. And in this direction, we have taken up a service called as Gramin Krishi Mosam Seva. We will be discussing about that. If you just look at the crops in India, you will find that the major crops come off during this Kharif season or the monsoon season. Because in India, most parts of the country receives about 70 to 90% of the annual rainfall during June to September. And this amount of rainfall is not only utilized for in situ cropping, but also this rainfall is utilized for storing the reservoirs and hence to go for irrigations in terms of stress management. So if you just look at, you will find that the crop production deviation for any year is a measure of the impact of the monsoon rainfall for that year. It has improved. So therefore we say that monsoon is life. If you remember the major famines in the past, you will find that it has been attributed to the weather. But recently, if you just remember the years like 2014 and 15 consecutive droughts in terms of the deficient rainfall, the country has very well managed itself and ensured the food sufficiency. So it has been possible because of the many initiatives taken up by the Government of India, research institute, scientists, engineers working in the field, starting with the basic science, R&D and applications, early warning, and management practices. It has helped to come up to that level where India is now self-sufficient in terms of the food due to this advanced agriculture. But still there are scope to improve further, minimize the losses and utilize the maximum resources available for the agriculture. If you just look at the Indian monsoon and economics, you will find that there is a severe impact of the monsoon on the economics. A recent study by Gadgil and Gadgil in 2006 found that impact of a severe drought on GDP remains 2 to 5% throughout, despite the substantial decrease in the contribution of agriculture to GDP. In the bottom figure, you can find out that how the contribution of agriculture is being reduced over the years, but still you will find that there are 2 to 5% contribution to the severe drought. On the other hand, if you just look at the labor forces occupation, you will find that in agriculture there are 47% of people engaged, whereas in industry 22% and service sector 31%. So how does it? What does it mean that a large amount of population are still dependent on agriculture, and hence we have to address the requirements of each and every farmers. So considering this, actually, India Meteorological Department started thinking of providing the weather forecast services for agriculture. But it is nothing new at present, whatever you see. If you just look at the history of weather forecasting in India, you will find that about 3000 BC era, in the Vedas and Upanishads, you can find the serious discussion about the process of cloud formations and rains and seasonal cycle caused by movement of Earth around the sun. You can also find out the informations in Brihad Samhita, Baramir's classical work, 500 AD. So where you can also find out that there is a phrase written as Adityat Jayate Vrishti. If you know the Sanskrit, Adityat means from sun, Jayate means is created, Vrishti means precipitation, rainfall. So that means sun creates rain. So this is the meaning of Aditya Jayate Vrishti, written in Brihad Samhita. And it has been adopted by India Meteorological Department, its emblem. So this itself indicates that in ancient literature also people understood the mechanism of weather and role of various forces acting upon it, and hence tried to understand and predict the weather. If you come up with the recent history, Kautilya's Arthashastra contains the records of scientific measurements of rainfall and its application to country's revenue and relief work. Kalidasa mentioned in Meghadoot about the different types of clouds, how they are moving as per the winds in the atmosphere. Especially he talked about the monsoon clouds. In the recent time, in the instrumental age, if you just look at, yes, India Meteorological Department came up into existence in 1875 in British era, after 2 devastating cyclones affected eastern India and Bangladesh, then of course India in 1864, and then we have the famine-like situation in 1866-67. In 1875, we came up with India Meteorological Department. But prior to that, the first observatory was established in 1785 in Calcutta, in Madras in 1796. The first weather warning was given to the ships through Calcutta port in 1868, though IMD came into existence in 1875. So therefore, weather monitoring and forecasting in the country is very old. And we are proud to have the wealth of informations. India has contributed a lot of research and development in the field of weather forecasting in those years also. You can find out the publications, Asiatic Society of Journal. You can find out naming of cyclones by the British India by Henry Paddington. You will find that IMD was the organization which used telegrams to collect the observational data and sending in the warnings. IMD is the first organization to have a switching computer, message switching computer, to support the global data exchange. So what I want to say that even though you find now the satellites, radars, and other latest tools and technologies, in the olden age also, IMD was to par with other leading centers to have the observational networks of that day. As far as weather forecasting is concerned, you will find that people have tried, therefore, to predict weather in different spatial scales and temporal scales. Knowingly or unknowingly, every individual becomes a weather forecaster in the morning of every day. Because we believe in the proverb, morning shows the day. So we come up from the bed every day, just look at the sky and predict ourselves, how will the day be? If you're planning to move somewhere, you predict yourself before visiting IMD's website or forecast, you predict yourself, how will the day be? That is the morning shows the day concept. But in weather, this concept does not work. Just like you told in Cuttack today, the morning does not show the day sometimes because of the rapid changes in atmospheric parameters. And hence the rapid changes in weather. But the climate does not change so rapidly. It is a slow process, but weather changes very rapidly. So people have tried to predict. If you just look at various types of forecast ranges at present, it varies from a few hours to a season. Just like we are predicting the long range forecast of monsoon for June to September. Also, we are predicting rainfall or any severe weather parameter for Cuttack or Bhubaneswar or any particular city or towns. So basically, you have therefore short to medium range forecast up to 10 days. Then you have got 10 to 30 days forecast that is called as extended range forecast or S2S predictions. That is soft seasonal to seasonal, S2S predictions. Then you have got seasonal forecast from 1 month to 3 months or 4 months or a season. While seasonal forecast is an atmospheric phenomena, while seasonal forecast is a climate phenomena, it depends upon the climate variables like El Nino, southern oscillations, sea conditions, sea ice, etc. The 1 to 10 days forecast depends upon the atmospheric phenomena, the atmospheric measurements, basically, for example, observations from the atmosphere, earth, and the oceans to define the initial conditions. In the middle, you have got the S2S, that is sub-seasonal to seasonal predictions over the next week 1, week 2, week 3, week 4. If you just look at this diagram, you'll find that the predictability or forecast skill is quite good when you go for day 1 forecast or hours forecast, 6 hours forecast. As you go away from day 1 to day 10, the forecast accuracy gradually decreases. You have got a fair forecast accuracy in terms of the seasonal forecast. When you go for seasonal to sub-seasonal forecast, your forecast accuracy is not so good at present. But still, people are trying over the world, and we want to come up. We'll see how far we can provide sub-seasonal to seasonal forecast to various types of activities, including the agriculture. Because agriculture is such a process where you need forecast in the seasonal scale to plan it. Whatever variety you will go for example, rice. When should you go for soil? When will be the onset of rain or onset of monsoon over the region so that you can go for sowing? Whether you will change your practices accordingly. At the same time, over a few hours, over a few days, for application of various practices, you need short-term forecast. But you have to plan again if there is a hot spell or cold spell, you've got a heavy rainfall spell, or you've got a dry spell. You need information, say at least a week advance or 2 weeks advance or 3 weeks advance, so that you can take proper steps for that purpose. So considering all these, India Meteorology Department provides weather and climate services for the self-reliant India. You will be happy to know that India Meteorology Department is self-reliant to provide the weather and forecasting services with the help of the sister organizations in Ministry of Earth Sciences. We have our own computing system. We have our own forecasting models. We have our own observational data. We have our own satellite and radars. So we do not depend upon other countries for providing the weather and climate service informations to our people. At the same time, we also go for global welfare. All our products are available to all the countries in South Asia, Southeast Asia, Middle East, and hence we have a role as a global player and regional player for the welfare of the region. So basically, India Meteorology Department ensures the meteorological observations and forecast for optimum operation of weather and climate sensitive activities. Hence, to enable the enhancement of economy. As for our vision, we have the target that no weather hazards should go undetected and unpredicted. There should be accurate warning against hazards with reasonable lead time, triggering response from disaster managers and public to save life and property. We take specific steps for optimizing the information on weather and climate, for weather sensitive activities, for management of natural resources like agriculture, water, power, energy, environment, etc. So considering this, what we go for, actually, we go on monitoring continuously, round the year, round the clock. We monitor land, ocean, and atmospheric states with an array of observations, with spatial dense observational network, both direct and remotely sensed, and also temporally frequent observations. Based on these observations, we run our computing system. We have an array of numerical weather prediction models. All these models are run with the help of the high performance computing systems, which are a facility of 10 petaflop at present, and develop the products. And these products from the numerical weather prediction models are post-processed to prepare the weather service for the general public, disaster managers, agriculture, and various applications. And these forecasts range from nowcasting a few hours, short range forecast 1 to 2 days, medium range forecast few days to week, extended forecast 1 week to month, and seasonal forecast few months. For example, June to September monsoon rainfall, January to February, March or winter temperature, for March, April, May, or April, May, June for summer temperature. So like that. We also go for climate scale forecast in terms of the climate phenomena like El Nino, Southern Oscillation, Mrityunjay oscillations, that's governing forces in the atmosphere, Indian Ocean Dipole, etc. And finally, we provide the forecast at location, block, district, meteorological subdivisions, river catchments, state and homogeneous regions. And also we provide this forecast basically adopting latest tools and technology and 3 methods. One is the synoptic method. Synoptic method means understanding the observations and utilizing its knowledge, experience, expertise. I would say that synoptic method is lost like a medicine specialist. It utilizes all types of diagnosis and writes the prescription, and hence the forecast in this case. The statistical methods, these are basically utilized to post-process the output from numerical weather prediction models and hence have very location specific informations. And dynamical methods or numerical weather predictions, this is the backbone of forecasting in the world and also in India Meteorological Department. We have got many applications. You will not find any sector within India which is not influenced by weather and climate, and hence also we do not leave any sector where we do not reach. We try to reach out each and every sector where socioeconomic activities are influenced by weather and climate. And we try to develop some kind of collaboration, cooperation with observations, each organizations, so that a collaborative approach is obtained, maintained to solve the people. We provide early warning and mitigation for post-severe weather. We also provide technical support for vulnerability analysis and risk assessment. We have the technical support for preparedness and planning by the disaster managers and various application services, and of course the natural resource management. Now, if you just look at the weather forecasting, agriculture, and its evolution in India in the modernized period, you will find that again this Agronomic advisory services started before the independence. In 1945, Farmers' Weather Bulletin was started in the country, considering the impact of weather on the agriculture. Then in 1971, there was a recommendation of the National Commission on Agriculture for Agronomic advisory services, and hence it was augmented in 1977, issuance of Agronomic advisory services bulletin at state level. It was commenced in Madras, Chennai, then it was extended to all the states. Then we have, over the years, a center coming off in National Center for Meteorology Weather Forecasting, dedicated for agriculture, for identification of agroclimatic zone as per the Government of India requirement and the states. We identified 131 agroclimatic zones, considering, of course, the geographic boundary and the political boundary of the country and different states. And accordingly, the integrated agronomic advisory services for 131 agroclimatic zones started. Gradually, it was given at the district level. And finally, we introduced recently the Gramin Krishi Mosam Seva, aiming at reaching out each and every farmer in the country, in the village. The experimental block level forecast started in 2018. And from this year, we are providing block level weather forecast for all the blocks in the country. If you just look at the needs in different scales of agriculture, there is a need for seasonal and monthly forecast for readiness and strategic planning of each and every individual crop. You need fortnightly forecast for preparedness and tactical decision making, just for example, irrigation scheduling or pest and diseases or sowing or transplantations. Then you have got nowcasting for 3 hours and meteorology forecast, so up to 10 days for operational farm applications and disaster management. This part is very important, specifically for disaster management to minimize the losses, and specifically for farm operations. So nowcast, so to meteorology forecast are the real forecasting applications, which has shown the potential in recent years to play a dominant role in management of the crops. The overall objective is to minimize the input cost through planning, adopting, and scheduling various crop practices based on weather information, minimizing the losses due to hazards and disasters based on early warning, and maximizing the crop yield through use of dynamic crop weather calendar, pest weather calendar, and all the above, as mentioned. If you just look at a little further, when you go for the forecast in short to medium range and nowcast, that is up to 10 days, here we have the issue of early warning to the farmers. We go for evacuation if there is some kind of disaster risk. We suggest the livestock evacuation also. We take initiative for protecting the grains and seeds and equipments. We go for harvesting the crops if it is in the harvesting stage, if there is a warning due to any particular disasters or any severe weather or high impact weather. We also go for index-based insurance payments, etc. to farmers. Of course, I don't know how far it is implemented in the country. And we go for the forecast 2 weeks to 2 months. We go for monitoring the agricultural outputs in the planning stage. You know that we have National Crop Forecasting Center. It goes on predicting the crop output based on each individual month's weather informations and other practices. We go for adjusting the planting, irrigation, pesticide, fertilizers, and harvesting schedules. We go for support pastoralists, commercial destocking, vaccination, diagnosis, and treatment of diseases. Provide nutrition for poor breeding animals. We also think about providing materials and support for protection of livelihood assets, activate market systems, pre-position grain and seed protecting bags, provide cash transfers, which is the case nowadays. In the seasonal forecast, we utilize it for selecting flood and drought-resistant crop varieties and crop diversifications, plan use of pesticides and fertilizers, plowing, tilting, tilling, irrigation scheduling, transplanting, etc. So as to limit the crop failure. We also ensure the access to agricultural risk insurance, utilize the nature-based solutions for protecting agricultural assets, and develop the contingency plan for crop failures. So all these things can be taken off or being taken off by each individual farmer and also the managers like agricultural scientists, district and block agricultural officers, even the village level agriculture officials, and of course, at the national level, the economists and planners. Now I'll just come off out of these three categories of forecasts one by one. To begin with, let me present the long-range forecast for agriculture. As all of us know that from very old age, we are continuing the long-range forecast. Very systematic long-range forecast came up in 1988 with 16-parameter regression model, which was further improved to 6 parameters model, 8 parameters, then 6 parameters. Then we came off in 1997 experimentally some kind of modeling system. Then recently, in 2007, we adopted a dynamical forecasting system, the climate forecast system, under the monsoon mission that was going on. We have the statistical and civil forecasting system and the dynamical monsoon mission coupled forecasting system, climate forecasting system. But this year, we further went on improving our monsoon forecast. We have introduced this year, instead of one dynamical model, we have gone for a multi-model ensemble. We have selected a good number of the best dynamical models available in the world. We have gone for some statistical treatment and developed a multi-model ensemble. And through this multi-model ensemble, as all of us know, that we have issued the forecast on 16th of this month. For the first time, we have introduced a special pattern of probability of forecast of rainfall across the country for the season, June to September. In the second stage, which will be issued end of May, we will provide the update of the seasonal forecast, again the special distribution of rainfall predicted over the country. And also we'll go for the seasonal forecast for the 4 homogeneous regions of the country and the monsoon core zone. In the below diagram, you can find out the monsoon core zone, which extends from Odisha to Gujarat and Rajasthan. This monsoon core zone is very important because if you just look at the rain-fed region, just in the middle figure, the rain-fed region and monsoon core zone is almost same. So therefore, the basic objective from this year will be to predict the rainfall for this rain-fed region, so that you can have the specific planning for this rain-fed region. Further, we will also providing the forecast for each individual month of June, July, and August, September by end of May, end of June, end of July, end of August. And this forecast again will provide a special map, just like you have seen right inside here, the special seasonal forecast map for the country as a whole in June to September issued on 16th. So we have just verified based on the hindcast how good this new system, and we'll find that it picks up very well, and the standard error of this multi-model ensemble is quite less compared to the individual dynamical forecasting systems and also the statistical ensemble forecasting systems. It has got an average absolute error of about 7%. And below, you can find out that the various modules are taken into consideration, and multi-model ensemble is developed using a robust statistical algorithm to provide a probabilistic forecast across the country. Now, when you go for the sub-seasonal to seasonal forecast, that is for 2 weeks or 3 weeks or 4 weeks, etc., you will find that it is very important for crop management, irrigation decisions, product marketing, input use, etc. So what we do actually, these forecasts can be utilized just like a ready, set, and go. I'll just explain a little after. The seasonal forecast just helps you to have a readiness, whereas the seasonal forecast, which is followed by this sub-seasonal forecast or extended forecast, helps you to be set for actions. And short to medium forecast or nowcast, which is issued for a few hours up to say 7 days, that gives you to go. So this is the concept of ready, set, and go. So we'll see what do you mean by that. Actually, this is just depicted here. So seasonal forecast of monsoon has just told this year to be ready. This year we are expecting normal rainfall, 19% of actual. But we have told that eastern and northeastern parts of the country, especially North Odisha, North Chhattisgarh, Bihar, Jharkhand, adjoining areas of East UP and Gangetic West Bengal, to have a probability of below normal rainfall activity. So this type of information will help now the disaster managers, general public, agricultural scientists to plan, to be ready for the season itself. They can design their emergency preparedness and response, begin preparation and monitor. Now they will go on monitoring. Now with this sub-seasonal forecast which is being issued now, which will be valid for every month, we are giving some kind of forecast for next month, and also for next 2 weeks to 4 weeks forecast is being issued. So here it will scale up the preparedness. If our forecast goes on continuing telling that yes, we are expecting this type of behavior, then it will help the preparedness and introduce the forecast based actions. But the last moment when they are giving the forecast for next 7 days or next few hours, that is weather forecast, now they activate the response. Immediate response has to follow by the agricultural practitioners, farmers, managers, disaster managers for immediate actions. So this is the scale of activity for our extended range forecast. We go for a multimodal ensemble for our extended range forecast. We utilize our atmospheric model, GFS, but also the climate forecast system, it is climate model. And utilizing both, we create a multimodal ensemble. And based on multimodal ensemble, give the forecast for basic parameters like wind, rainfall, temperature maximum, temperature minimum. And also we provide the forecast for week 1, week 2, week 3, and week 4. We also provide the probability for various types of severe weather which is expected during this week 1, week 2, week 3, and week 4. So therefore, what I want to say that this S2S prediction or the extended range forecast for agriculture and disaster risk management can be utilized to have your early warning for heat and cold waves and the mitigation plans preparedness. You can also plan for floods and drought preparedness if there is a prediction of dry spells or wet spells. Cyclone preparedness and mitigation measures. Nowadays, we provide the extended range forecast 15 days in advance about the occurrence of the genesis of the tropical depressions and cyclones of Bay of Bengal and Arabian Sea. It will also help the heavy rainfall warning and mitigation if you are expecting wet spell. So therefore, it could be the button like ready for actions. The Sendai framework also tells that we should go for these S2S predictions, linking the seasonal forecast and short to medium forecast through this S2S forecast. So this is just an example of the extended forecast for hydrological applications. For example, occurrence of heavy rainfall, flood, reservoir operations, and disaster management, enhanced agriculture. So this type of forecast is provided every week or across the country. This superimposed the district-wise map, but I will tell you the forecast accuracy of this extended range forecast is quite good, up to 2 weeks, and at the meteorological subdivision level, not at the district level. We are planning to improve it at district level, but it is not good at district level. So therefore, it gives a general idea about whether there will be a deficit rainfall or excess rainfall for the state of Odisha, not for the Cuttack district or Khordha district, because of the variation or error in the spatial and also the temporal predictions. On the right hand side, you can find out that is a standardized precipitation index, which is also provided based on this rainfall forecast. The standardized precipitation index is also provided, and it helps the management of the crops. So this is another example of the forecast for river catchments. We provide forecast for river catchments. We calculate the volume of water in each river catchment, and this is utilized by the disaster managers to provide the guidance to the farmers and various agricultural practices. So it has got very good skill. If you can find out, the model can provide the occurrence of hot spell, cold spells, and wet spells and dry spells. It can provide very good information about the transition from weak monsoon to strong monsoon, from strong monsoon to weak monsoon. This is just an example. Not only the rainfall, but also it helps in providing the forecast of various types of processes associated with this phenomena, like strong monsoon and weak monsoon conditions. This is just an example of the aridity anomaly. We provide a forecast of the aridity anomaly outlook for a given week, and also we provide the standard precipitation index, as I told you earlier. We provide this aridity anomaly in terms of the non-arid, mild arid, moderately arid, and severely arid. And here we provide the extremely dry, severely dry, moderately dry, or extremely wet, severely wet, or moderately wet, like this with different color codes. So this is just an example of the standard precipitation index for the listed week. We provide the information for week 2, week 3, week 4, etc., based on this forecast. So this is just an example of the experiment forecast of Psychogenesis. If you just remember Cyclone Amphan last year, it was predicted about 14 days in advance that some kind of genesis is going to take place over the Bay of Bengal, and it was followed by the short to medium range forecast, giving the warning 5 days in advance, and hence enabling disaster managers to minimize losses of lives. So this is the heat wave forecast, which is also provided every week, identifying the area which is experiencing or which is likely to experience the heat wave conditions. We provide the information in terms of T max, that is maximum temperature, in its anomaly, and the area of occurrence of the heat waves. Similar is the case with respect to cold wave, and all these information external range forecasts are followed by short to medium range forecast for various sectors, including agriculture. In the short to medium range forecast, we provide information in 3 categories. One is the simple forecast for short to medium range, then multi-hazard early warning, then we have got the impact-based forecast informations and risk assessment to various sectors. Before proceeding in details, I just want to tell you that India is such a country which experiences all types of natural hazards, and about 80% of the natural hazards are weather related. We have got the cyclones, we have got the heavy rainfall, floods, droughts, rainstorms, and we have also the thunderstorms, hailstorms, and squalls, tornadoes. And people die nowadays because of the thunderstorms more. Number of deaths, lightning is more than the deaths due to cyclones nowadays. It has been reversed. Number of deaths due to cyclone has been reduced to being less than 100, whereas the number of deaths lightning is increasing because of many factors, including exposure. Nowadays, people are more exposed to the outer conditions. Now, to carry out all these multi-hazard early warning and forecasting, we have got observational network across the country. From the surface, we have got the automated stations, gun gauges, observations, aviation, ships, etc. From upper air, we have got the radars, we have got the aircraft, we have got the wind profilers, we have got the balloons released with the sensors. And from space-based observations, we have got geostationary satellites and orbiting satellites. All these observations are utilized to define an initial condition of the atmosphere, ocean, and earth system. Why? Because it has been recognized that weather forecasting is an initial value problem. If you can detect well, you can predict well. That means if you have a very well-defined, accurate initial state of the ocean, earth, and atmosphere, and that initial state can be utilized to predict the atmosphere well, and hence the weather. And to do that, you have got an array of numerical weather prediction models. We have got the individual deterministic models, also we've got the ensemble models. We have got the regional models, we have got the global models to provide forecast for across the globe. All these model forecasts are provided to the forecaster along with those initial conditions. And forecaster, utilizing a decision support system, develops the forecast. And this forecast is end forecast. The end forecast is different from the forecast generated from the numerical models. The forecast numerical models are converted in layman language, that is called as public weather service. And those end forecasts are given along with the impact expected or adverse weather expected, and hence the action to be taken. And finally, when it goes to decision maker, it is an end-to-end solution with hazard and risk analysis, preparedness, and early warning provided by the agency. The disaster managers and various agencies take the preventive measures and mitigation processes. So this is not the various types of observations depicted here. You have the surface, upper air, marine observations, aircraft, satellite, weather observations, radars, etc. And this is the network across the country. You will find that India has a very good network of observations. The leftmost, you can find out the radar network, but still the entire country is not covered with radar. We are planning it for next 5 years. The entire country should have the radar. But however, east and west coasts are well represented, which is very prone for various types of weather-related activities. Also, I've got the SCAT-SAT in between here, and I've got all the observatories across the country and satellites and radar images, etc. So this is the data exchange, that is information and communication system. You'll be happy to know that India Agriculture Department acts as a regional telecommunication hub for exchange of information with all the countries in the world. And we ensure non-stop exchange of data because weather has no boundary. If you really want to have information about the weather over Delhi, you need information over Afghanistan or Iran to have a lead period of information over Delhi. Similarly, if you want to give a forecast for Southeast Asia, you should have information from Southeast Asia or from Northwest Pacific. So like that, we have a major role globally and also for the national purpose. We exchange all types of information utilizing latest information communication technology. So this is the modeling system in India. We have got various types of models for seasonal forecasting or extended range forecasting. And finally, when you go for warning, we have got multi-model ensemble forecasting system and ensemble-based forecasting system. And for few hours forecasting, also we have got the systems like high resolution rapid refresh weather research and forecasting system. So it provides you a very good accuracy up to 5 days. Globally also warning service for 5 days. And in India also provide warning up to 5 days. But if you just look at this cone type behavior of this warning red color, you'll find that as you move from day 1 to day 5, the accuracy gradually decreases. As you told that initial state of atmosphere determines the forecast. So initial state, that memory will not carry further, it will not go far away. Even though the predictability is up to 10 days to 15 days, but at present, the state-of-the-art numerical modeling system allows to provide warning up to 5 days, 1 day. So this is the forecasting skill of the country. You will find that in the cyclone, we are second to none in the globe. Our forecast accuracy is better than many leading centers in the world. The pinpointed accuracy of the cyclone Amphan, Filin, Fani has been globally highlighted by United Nations and World Meteorological Organizations. In the meantime, if you just look at the heavy rainfall, which causes floods, you will find that forecast accuracy is quite good. We have got about 80% accuracy in heavy rainfall warning. The thunderstorm, which is a killer nowadays in terms of the lightning, you will find that we have got very good accuracy up to 90% in 3 hours in advance. And day 1 advance or day 2 advance, if you go, it is about 65 to 70%. The thunderstorm is a very small scale system. It is very difficult to predict 5 days in advance or 3 days in advance. Only a few hours in advance you can predict thunderstorms. And hence nowcasting is the most appropriate method for thunderstorm forecasting or lightning. You'll be happy to know that India is among only 4 to 5 countries in the world who provide lightning warning. And you know, lightning is very important for farmers. It was a very difficult situation last year when 30 farmers died in Bihar in one single lightning strike. They were all working in the field. Warning was provided, but it could not reach to the farmers. So there are issues. Apart from forecasting, we have to go for extension of services so as to reach out each and every farmer so that they are safe and also they keep their fields safe from various types of disasters. And the bottom one, you can find out this is the heat wave warning scale. It is also improved in recent years. There's a sharp rise in warning scales in terms of weather detection. So as a result, what you find actually, there has been minimum loss of life to heat wave also. So considering all this improvement in forecasting, what we have done actually, we have gone for some kind of impact-based forecasting. What we do actually in this impact-based forecasting, we utilize the information from weather and translate it into the impact, and hence create a response scenario. So weather analysis and forecasting data is utilized to extract the relevant informations and we place it into situational context. For example, agriculture, considering the various types of crops, the stages, crop weather calendar, pest weather calendar, and finally we decide what is the impact expected and the response scenario to be. And accordingly, the mitigation strategies are adopted. So therefore, if we just look at these are the two edges. One is the weather information provider, other is the weather impact user. These two has to merge with each other, hence a rectangle should form. That means there is a need for active collaboration among the early warning service provider or weather service provider and the users, the stakeholders, so that combinedly, what we feel now actually as a weather forecast, we feel that our forecast is very important. But actually, when it reaches to the general public, it is not so important. There are many other factors which govern at that time. And they also feel that all these factors are important and weather forecast is not important. But we have to therefore merge these two edges. These gaps should minimize and they should merge with each other so that we can have a very realistic dynamic impact-based forecast and risk assessment for each and every applications in the agriculture. Okay, so this is just an individual case. I just want to say that this is the cyclone forecasting. I will not pass through it. I just want to say that we have in place a very well-defined system to provide forecast accuracy up to 5 days in advance for the cyclones. So this is the impact-based forecast for agriculture. You can find out for each and every district and block, we are providing impact-based information. This is just an example how we are providing different stages like stage 1, stage 2, stage 3, stage 4 forecast for different districts along with the impact informations. So this is the flood forecasting. Central Water Commission is the nodal agency, and the Environmental Department provides the rainfall information, rainfall forecast, quantitative precipitation forecast, and also the model guidance. And utilizing this, they run their hydrological models and provide forecast for 153 river catchments. And this is another hazard which also affects the farmers, that is South Asia flash flood guidance we have introduced. Here we have identified 30,000 watersheds in the country. In these 30,000 watersheds, we provide daily 4 times the information valid for next 12 hours. If in the monsoon season we are expecting a flash flood, that means heavy rainfall in a short duration, we provide this guidance. And it has been inaugurated last year, and this year it will be fully operational to provide this information. And this is the heat wave and cold wave information. So we are providing an interactive map for each individual station. You can find out whether heat wave is there, whether heat wave was there for last 5 days, whether heat wave will be there for next 5 days, and what action has to be taken and what precaution has to be followed. Similarly, for thunderstorms, you will find that we have a very good observational network utilizing our lightning warning system with the help of Indian Air Force and Indian Institute of Tropical Meteorology. We have got lightning detection system based on the ground truth and also from the satellite, of course, international satellites. We have got many various products generated from satellites and radars for monitoring of this lightning. This is the modeling system for lightning, where we can provide lightning forecast for every 3 hours, valid up to next 24 hours. And as a result, at present, we are providing thunderstorm and lightning forecast for 739 districts across the country and 894 stations, individual stations. Now this number has gone up to 1,085. So we are planning for each and every block representative, we should have this nowcast, so that every farmer in the block can have the information whether it is going to occur in their area, and at least 45 minutes advance with the help of the Damini mobile app, they can have the information about the lightning. So this is the end-to-end solution of the early warning system involving the general public, disaster managers, media, and various application services. For the warning dissemination, we utilize all types of network. We do not depend upon only one, because redundancy is key to success in warning dissemination. So we utilize all these, and recently we have come up with the Common Alert Protocol. The Common Alert Protocol is being developed by National Disaster Management Authority, and it is being adopted by India Meteorological Department. Through this Common Alert Protocol, there will be information in local language. There will be information in all modes, starting SMS, WhatsApp, Twitter, and All India Radio, Doordarshan, all will be targeted for that purpose. It will be very specific to a particular severe weather. It will be provided at the district level. And we are also going for the space-based information like GAMS, Gagan Messaging System, and NAVIC. This is especially for the remote areas like deep seas and also the Himalayan areas where we do not have the sufficient communication network. The space-based communication is being developed by Indian Space Research Organizations along with the Ministry of Earth Sciences, IMD, and ICAR. So you have the various types of social media by IMD, and also you have got the mobile apps as shown here. So we have also gone for some kind of awareness campaign along with national authorities. You can find out various awareness campaign products available in the various websites for various types of severe weather. This is for heat wave and urban floods, heavy rainfall, lightning, etc. So, what I want to just highlight here that during this COVID-19, it has become very difficult actually to manage the weather and forecasting system to ensure the non-stop service. And it was very difficult time during Cyclone Amphan. But you will be happy to know that entire country was awakened with the information provided by India Meteorology Department, starting from the block level offices to the office of the Prime Minister. Everybody took actions. National Crisis Management Committee was taken up, and Honorable Prime Minister reviewed. I briefed Honorable Prime Minister and Honorable Home Minister and the Cabinet Secretary almost in a regular manner. And as a result, a success story was wrought by each and every one of us to minimize the losses due to this Cyclone Amphan and similar cyclones afterwards in the Nisarg. So I want to say that the scientific community has come off well to help and to work in this distress condition like COVID-19 and wrote a success story. This is just an example of how the number of deaths has been reduced. You will find that there is no cyclone in recent year where number of deaths has increased more than 100. It is just recent cyclone you see just 5, 9, 11, 25, 13, 14, etc. The number of deaths has been significantly reduced. Similarly, in the heat wave also, you will find that when there was more than 2,000 deaths in 2015, now it is only 29 in 2018, and last year there was only 4 deaths last year because of the years. As a result, we have got a lot of appreciations worldwide. We're coming to the specific agriculture sector. Yes, we also have some kind of special products for agriculture in short to medium range. What we do actually at present, we provide 2 special bulletins on Tuesday and Friday. We provide forecast rainfall, wind speed, direction, temperature, humidity, minimum temperature, clouds, etc., which are required for agriculture. These parameters have been developed in consultation with the agricultural practitioners, district officers, scientists working in the field. And all these bulletins are provided at the state level and district level. And recently, I told you, we have gone for the block level information. You'll be happy to know that about 665 bulletins in 14 languages are prepared every Tuesday and Friday, and they are communicated through various means and also uploaded in website. We also go for conducting farmers awareness program. As you told, NRI also have 2 KVKs. We also go for KVKs and MFUs, which are located in KVKs and DAM, District Agricultural Meteorological Units, which are an integral part of this service. So what I want to say that the Agronomic Advisory Service is another success story in the country. It has been highlighted in other parts of the world. It has demonstrated how an integral approach, a collaborative mechanism in the country can help the farmers to maximize their output. So these are the collaborative agencies working in this field. You will find that there are many who are involved with this Agronomic Advisory Services, starting with state and central agriculture department, agricultural universities, institutes, and also the service media, etc. So these are some of the examples. I'll just move quickly because I have taken more time perhaps. So I'll just take 5 minutes more. So you will find that this is just an example of the tabular form information. We also give graphical information. This is the information about the past weather in a particular district and also the forecast for the next 5 days and 7 days. And apart from all this forecast, what we want to say that we give the impact information in terms of the cultivar selections, sowing and harvesting dates, irrigation management, plant protection from pests and diseases, livestock management like shelters, health, nutrition, fertilizer applications, and measures against adverse weather conditions. All these are also integrated with the bulletins. This is just an example of various types of impact and information provided. It is written in Odia language. An example here for the district of district, and you will find in English language. So this is done keeping in view that the languages are different in different parts of the world. So we should go for communicating each and every farmer. So we also have a national agronomic advisory bulletin accumulating all the information across the country every Tuesday and Friday. So these are some of the products which we develop for agriculture purpose. For example, we prepare the NDVI, normalized difference vegetation index. We go for standardized precipitation index. We go for daily soil moisture and its forecast. So it helps the assessment of the situation with respect to individual crops and its impact. We also have, as I told you, apart from tabular form, we also have the information for each and every district now, each and every block, with respect to the parameters of the agronomic advisory services like maximum temperature, minimum temperature, diagonal variation of temperature, rainfall, cloud cover, wind speed and wind directions, minimum relative humidity or maximum relative humidity, which are very much essential for agricultural practices. We disseminate all these agronomic advisory services through various means. One of the most important means is the SMS. We reach out to 43.37 million farmers in the country through SMS services. During Cyclone Amphan, 29 lakh farmers were provided the alert messages, and they were provided the information how to go for appropriate agricultural practices. Say, these SMS are provided through Farmers Portal weekly, twice on Tuesday and Friday. We also have the websites in different state level and also at the national level. We also disseminate our information through TV, various national TV and private TV, and especially the DD Kisan also provides all this information. We go for PPP mode, like say Kisan Sansar Limited or Reliance Foundations, MS Swaminathan Foundations, etc. We have the latest social media tools. You can just find out the Meghdut, we have got Mosam, we have got Damini, and also for various KVKs, you will find out that there is eMosam, say for example, Haryana Agricultural University. So there are many, and we also have got the Kisan Suvidha from Department of Agriculture and Cooperation and Family Welfare, and all these are helping us to reach out. But still, I will say you, considering the total number of farmers is 12 million, we are reaching out to 43. Therefore, there is still scope to go further improvement of the dissemination. Now, if we just look at whether the service is helping the farmers or not, we go for assessing the impact of the service time to time. The first assessment was taken up in 2010, then 2015, then 2019. You will find that there has been significant contribution of the services. As for the latest 2019, you will find that average annual income of the surveyed farmers was 2.43 lakh with modification in 1 to 4 practices. We examined 9 practices, agricultural practices. 98% of farmers made modifications as per the survey. And those farmers who adopted 1 to 4 practices out of 9 practices, they have 2.43 lakh average annual income. Those with 5 to 8 practices, they have 2.48 lakhs. All 9 practices, it was 3.02 lakhs average annual income. And those who did not follow the agronomic advisory service, they had the income of 1.98 lakhs. That means there is a gain of about 1 lakh rupees in their annual income because of the agronomic advisory services. So 80% of farmers receiving information were reported to have reduced losses. So there has been, there are 2 types of survey. One is the above poverty line and another is the below poverty line. So what we found actually, the estimated additional annual income is 12,500 for agricultural household belonging to below poverty line category in rain-fed areas. So total income has been about rupees 13,031 crores per annum in the rain-fed districts. So by that way, if you just look at the accessibility of the information to the farmers, you will find that it was just 7% in 2015. 2015, only 7% farmers utilized the forecast, whereas in 2019, 59% of the farmers surveyed showed that they are utilizing this forecast information. So we also go for this dynamic feedback mechanism to acquire information from the general farmers and agricultural practitioners, agricultural scientists and engineers to assess ourselves, to improve our forecast. And this is the practice which is followed in IMD. So based on this, recently we have just conducted a feedback of Agronomic advisory services, which was dynamic and real-time. End of season report we prepared based on this questionnaire, and case-based success stories also we carried out regarding cutting input cost, higher productivity, etc. So it was just some it was about 4,000 inputs were taken. So what we found actually, there is different types of aptitudes and attitudes of the farmers. So, for example, if we ask the regularly bi-weekly forecast agriculture advisory bulletin whether they are going through, regularly they are going through 91% and irregularly 8%, 8.1%, and somewhat regular they told about 8%. Similarly, when you ask that whether you are utilizing social media like Facebook and etc., so maximum persons responded that they are liking to use WhatsApp. So through WhatsApp, perhaps it is free and it is very easy to extend from one person to other persons. So like that, this survey was conducted for Kharif and other practices also. So another result what we found there, do you follow weather forecast based agronomic advisory bulletins for your farm operations? Yes, 98% told yes, 2% told no, they do not consider. Then how relevant it was when you asked, they told that yes, 70% told highly useful, and 29% told that partially useful, and 1% told it is not useful. Also, we asked them what is the average percentage of production loss due to the crop during the crop season due to harmful weather. And we found that yes, there is substantial crop losses due to the harmful weather, especially the disasters. Also, people responded with respect to what type of utilities they are utilizing, whether they are satisfied or not. So 35% told highly satisfied and 58% satisfied. So there are certain people where there is scope further to improve the services. So it helps us to assess ourselves and provide the better service. So considering this, we are going for augmentation of agronomic advisory services. As all of us know that we are going for Gramin Krishi Mausam Seva. So at present, the district-wise Mausam Seva was prepared and provided. We have experimented block level. As I told you, from this year, we are providing all blocks forecast. And finally, the objective is to reach out to each and every village. So for this purpose, we are going to establish the district agriculture meteorological units. At present, we have established about 130 MFUs and 176 DAMUs. So target is 660 DAMUs across the country, and perhaps during next 2 to 3 years, we will be targeting that. And in this, we are also going to establish agronomic advisory, AWS. That means in the automated weather stations, we will have the provision for measurement of soil temperature, soil moisture. We are targeting for soil moisture in the root zone, that is 10, 30, 70, 100 meter depths. And also we'll have the information about extreme weather and the modeling. So at present, if you just look at, we are utilizing soil water balance model, land surface area model, and we are proposing to have the land surface data assimilation, LDAS, based on soil moisture up to 4 kilometer, weekly graded soil moisture based on the observations at MFUs and DAMUs. So combination of all available methods will help the accuracy of estimation and hence the forecast. The objective will be the generation of root zone soil moisture specific crop for specific crop and for specific locations from this modeling system. Now also we have gone for agronomic decision support system. We are transforming from manual system to automated systems where we have the state-of-the-art modeling systems, the observations, and then the processing and forecast generation and dissemination. And for this purpose, we also have a web portal. In this web portal, all these informations are being utilized by all our subject matter specialists and agriculture specialists across the KVKs and the DAMUs. So apart from that, we are also targeting for development of dynamical crop weather calendars and dynamical pest weather calendar. At present, we have the static crop weather calendar. For realistic impact information generation and assessment of the public, we should have a dynamical crop weather calendar. I urge upon the scientists and engineers to help in this regard, to collect all types of information from the research carried out in the past for various types of crops in the different types of districts or different agroclimatic zones, so that we can have a very realistic dynamic crop weather calendar with respect to different stages of the crops, with respect to different stages of the weather. So considering all these, if you just look at the weather forecasting is highly dependent upon the ocean and atmospheric technology. So there is an end-to-end integrated agronomic advisory services in the country, but still there is scope to improve further the agronomic advisory services with the further intervention of the atmospheric and oceanic technology. India Meteorology Department, Mr. Vasansis, is continuously strengthening and upgrading. But however, as I told earlier, it is a collaborative process. It is an integrated process where we need the active collaboration and integration of all the stakeholders, including the research institutes, universities, R&Ds, and application services, and basically the farmers also. So therefore, the research institutes like NRRI has a very predominant role in this regard to help the farmers, and help the early warning service providers like India Meteorology Department, and work together. And I hope the wealth of information which is available through India Meteorology Department with respect to past data and the real-time data, the organizations like yours can come together with India Meteorology Department and work further for the betterment of research and development in the field, and hence the application services. We have been able to minimize the losses to agriculture and minimize the losses of lives also. But still, with respect to data, there is scope to improve further with direct monitoring with respect to automated agromet automated weather stations, and also with respect to non-conventional data like remote sense data and crowdsourcing data. Recently, we have launched the crowdsourcing data. I think I request all of you to also utilize the new platforms being generated and help each other in generating the various types of sources of data. Also, there are new tools like big data, cloud computing, and AI/ML, which will also help in better decision making as it is being done in certain sources. Especially in the field of agriculture, there is enough scope to utilize AI and ML for decision making and for interpretation of the various model outputs and impact-based forecasting. Digital forecasting is the key of the success. We are just moving with the automated weather systems, with the automated decision support systems, and we are venturing to shift from manual process to digital process. Impact-based forecasting is best running, we have come up, but still there is scope to improve further, considering the dynamic crop weather calendar and dynamic pest weather calendar. Last mile connectivity, yes, it is still an issue for last mile connectivity, because there are still people who do not have the phones, there are still people who do not have the smartphones, there are still people who are not aware about various types of weather and its impact their own life and agriculture. So therefore, last mile connectivity in terms of the teleconnections, in terms of the awareness campaign, in terms of the linking out with each and every farmer is still a scope to improve upon. I thank you once again for giving me an opportunity to speak on this occasion, and I'm sure that NRI and India Meteorology Department can work together in the future to serve the last mile, the farmers. Thank you very much.
Thank you very much, sir, for a very comprehensive overview of how weather forecast is done and where India actually stands in the world scenario, and how forecasting service has broad spectrum impacts on almost all important sectors of the country. And also the significant role of IMD that IMD is playing. And it was great to have you, sir, for this Foundation Day lecture. And you would be glad to know that, sir, this lecture is attended by almost more than 160 people from different parts of the country. And also it's great to know that, sir, your institute also doing very good in dissemination of those information that you are generating by creating a lot of online tools like Damini, Megdut, and Motion. And now it's time to listen thank you very much, sir. Now it's time to listen to our president of this session, Dr. D. Mahapatra, Director, NRRI. Over to you, sir.
Thank you, Dr. Kutub. So before I start to make my comments, I have a request to Dr. Mohapatra, please. with your knowledge-packed deliberations, automatically there have been generation of lot of queries within our listeners. So if you can allow, can we have a question answer? And if you can allow, then I request Dr. B.C. Patra to coordinate from the chat box. The queries are already posted there.
Yes, please.
Sir, there are a few questions in the chat box. One by one, I will be reading, sir. One question has come.
Also mention the names.
Yeah. One question has come from one of our scientists, Dr. Suttapa Sarkar. She is from NRRI Cuttack. She is a rice breeder. She has asked, as long as, is there any long-term prediction? What is the expected frequency of summer cyclone in Eastern India in next 25 or 30 years? So that rice breeders can plan their experiments. And there, especially in Boro season in Eastern India, what happens, the panicles, with little moisture, the seeds started germinating in the panicle section. That is called as vivipary germination. So how to overcome that situation?
So thank you. I just want to mention here that the cyclones are considered as high impact weather event across the globe, and we have the notorious record of having 300,000 deaths in 1971 cyclone, Bhola cyclone, which crossed Bangladesh. And Odisha is one of the most severely affected state in the country due to the cyclones. We provide the cyclone forecast very accurately 5 days in advance with respect to its location, its track, its intensity, with respect to landfall and associated severe weather like heavy rainfall, wind, tidal waves, etc. And 15 days advance, week 1 and week 2 forecast we provide based on the extended range forecast, the area of genesis of the depressions and expected movement. But the seasonal forecast of the cyclones in this ocean basin is not attempted so far because the number of cyclones, if you just look at it, is only 5 in nature. 4 to 5 cyclones develop in the average. Sometimes it may go up, say, for example, in 18, 19, it went up to 9 and 10. But in general, it is 4 to 5 cyclones out of 80 cyclones developing over the globe. So again, if you just look at, unlike other ocean basins, we have got 2 cyclone seasons. One is the pre-monsoon cyclone season, or the summer cyclone season, that is April, May, June. Other is the post-monsoon cyclone season, that is October to December. Again, if you just look at October to December cyclones are about 4 and 1 in summer cyclone seasons. So considering this, the interannual variability of the number of cyclones are very high. And therefore, throughout the world, nobody has attempted so far to predict the seasonal frequency of cyclones in summer season or in post-monsoon season. We did some work in IMD. We developed experimentally 2 methods, but we found that accuracy is not there. So therefore, experimentally it is run within the house, but it is not shared with the public because it has no accuracy. And therefore, this is the case with respect to the seasonal. And again, if you just consider 25 to 30 years, yes, there are certain studies with respect to climate change. There are simulation studies and regional climate studies has been taken up with these RCMs. And we have a center called as National Center for Climate Change Research in Ministry of Earth Sciences, located in Indian Institute of Tropical Meteorology, Pune. So they carry out this study. As per this study, the temperature is rising and sea surface temperature is also rising. The conditions of sea surface temperature and the ocean heat content are favoring for more genesis and more intensity. But there are many other parameters, atmospheric parameters also. So as a result, I'll tell you the findings. I am a member of the International Committee for Assessment of Climate Change with respect to tropical cyclones. We have found out that the intense cyclones are increasing over Arabian Sea, but not in Bay of Bengal. The Bay of Bengal rather shows the decreasing trend in the total frequency of cyclones, but extremely severe cyclones does not show any trend. That means number of extreme cyclones remains same over Bay of Bengal, and it shows increasing trend over the Arabian Sea. But the Arabian Sea cyclones move towards west-northwest, and hence Somalia, Oman, Yemen, all these countries are becoming more prone for the extremely severe cyclones. Now, this is the fact detection. When you go for predictions, the prediction also does not attribute the global warming. There is very low confidence that global warming can be attributed to this rise in frequency of intense cyclones over the Arabian Sea. So therefore, considering this very low frequency of cyclones developing over this Bay of Bengal and seeing different regions, there is very low confidence to attribute to global warming about the future changes.
Thank you, sir. Thank you, sir. There is another question from Professor Swaroj Sanyal. He was our QRT member, and he's also a former Vice Chancellor of BCKV Kalyani, West Bengal. So he has asked one question, sir. By measurement of soil moisture in the root zone, do you mean that only 0 to 15 centimeter depth of soil moisture is measured, leaving the remaining depth of the soil profile moisture untapped?
No, we are planning up to 100, that is 0, 10, 7, 30, 70, 100, that type of measurement we are planning with this Agro AWS.
Okay, sir. So one more question is from Pusa, Bihar, Samastipur. So he has asked Dr. Dev, R.P. Dev, from Central Agriculture University, Pusa. He has asked about terminal heat is a problem in grain formation of wheat in North Bihar. Is it possible to minimize?
I am not an expert in this field. Actually, I can talk about the weather forecast, but its impact on termites, etc. I think agricultural experts can speak upon. If any expert is present in this forum, I will request to respond to this question. But I'll just respond a little more to the previous question regarding soil moisture. I want to say that this new venture we have taken off. Earlier, we have got the manual observations of soil moisture. Now we are going for automated observations. There will be, in the first phase, 200 Agro AWS with the soil moisture. And afterwards, we are planning for entire, each district will have the Agro AWS observations. I request all scientists and engineers working in this field to utilize this data, to come up how good it is, how can be utilized. There is enough scope. I'll tell you, we are very open now for the data. If any data is required with the past observations and for future all these automated data for their validations, applications, I'll be happy to cooperate and provide the data.
Sir, I'll take one or two more questions, sir, if you allow, sir.
Yes, yeah. Please.
Sir, one question has come from Dr. Rahul Tripathi, senior scientist from our institute, NRRI, Cuttack. He has asked whether the soil moisture product up to 60 centimeter depth have been validated for different parts of India. What is the technical that special resolution of these products?
Yeah, actually, we have just started established now 40 Agro AWS has been established in 40 districts now. It is still under the process of validation. And before establishment, we went for experimental, while deciding the vendor, we went for experimental work for 1 or 2 months. And based on that, it has been decided. So therefore, it is a continuous process. The validation will go on. But we have got the gravimetric data from the manual observations of the soil moisture. These are also being utilized in the past, and we are comparing this gravimetric and volumetric data also during this validation process.
Sir, one more question has come from Dr. Neha Parikh. She has asked, sir, is it possible to provide normal weather data to dear Damu that you know?
Yes,
Damu?
yes. Yeah. Yes. See, you are part of Damu. Okay, you are part of IMD. And any person or any individual, any organization working for research purpose, data are free. It is a collaborative. If it is collaborative research, there is no hesitation. And I always acknowledge the collaborations. So if you face any difficulty, please write to us. And I'm sure you will get the data. Normal data, whatever you are required, can be made available. Please contact our Climate Research Service Division. Now we have automated the data supply also. Please visit our climate data portal, data service portal. There you can enter, register, and get your data required.
Sir, last but one more question is there. It is from Dr. Bhaskar Gaikwad. He has asked whether the agronomic products and forecasting services of IMD are available in the web page for research institutes. If yes, what is the level of special granularity provided?
Yeah. So as I told you, the observations are available. And forecast part is also available at district level with the crop informations, crop advisories. Block level, about 2,300 blocks, you have got both weather forecast and crop advisories. And remaining blocks, it is only weather forecast. At present, all weather forecasts are being provided at the website. You can find out all our information at the website. We are trying to develop the web API also, but the website information is available. For certain products, APIs are available. You can write to us, whatever possible, we will provide you.
Sir, last question, sir, if you please allow, sir. There are several other questions, but due to paucity time, I will take up the last question, sir. He is Dr. AVM Subbarao from ICAR-Central Research Institute for Dryland Agriculture, Hyderabad. He has asked, sir, is there any periodicity for cyclone frequency in Bay of Bengal or Arabian Sea in that case? Why it is so frequent in Bay of Bengal side, not in Arabian side?
Okay. So there is, see, if you just look at seas, there is some kind of seasonal periodicity, I would say. Seasonal periodicity in the sense that we have the two seasons. One is the pre-monsoon season, that is April, May, June. Other season is the October, December. During monsoon season, usually we do not get cyclones, but in the month of June and September, during onset and withdrawal phase, we get cyclones. July and August, usually we do not get cyclones. It is mainly because the environmental condition during monsoon season is not favorable for development of cyclones. It develops the depressions, but very rarely it goes into the cyclone stage because of the high vertical wind shear in the atmosphere. And all these depressions develop near the head of Bengal, very close to the coast. So they do not find time to intensify and they move just inside the land surface. But during pre-monsoon season and post-monsoon season, factors are favorable. So therefore, unlike other ocean basins, we have got this type of two periodicity. One is pre-monsoon, other is the post-monsoon. Apart from this, within the year variations periodicity, there is no such significant periodicity from year to year variations. You cannot find out any significant periodicity. People have found out some kind of epochs, etc., but it is not so much significant. I will not mention here that type of findings. And as far as why Bay of Bengal gets more frequent cyclones, Arabian Sea, I'll tell you, Bay of Bengal is warmer compared to the Arabian Sea. This is number one. And if you consider the in-depth, that is soft-surface layer water heat content or seawater heat content, you will find that is also favorable over the Bay of Bengal as compared to, because of stratification, salinity factors, etc. The next point is that if you just look at the ocean current near Somalia coast or African coast or Oman, Somalia, Yemen coast, you will find that there is upwelling. So because of that upwelling, that brings out cold water to the top, and hence the sea surface becomes colder. Entire West Arabian Sea is colder. Therefore, whenever cyclone develops, and usually cyclone moves towards west northwest axis, it weakens and does not have stamina to intensify further. But in case of the Bay of Bengal, it does not happen like that. Bay of Bengal remains warm. The sea water heat content is more, and especially during the season of October, December, and April, May, June, over the Bay of Bengal, vertical wind shear across central Bay of Bengal becomes weaker, and that favors the development. So in situ development is quite more probable over Bay of Bengal as compared to Arabian Sea. Apart from that, the different ocean basins in the world, if you compare, Northwest Pacific Ocean is the most prone area for cyclonic activities. And because of the rotation of the Earth, which is around one axis in all ocean basins in the northern hemisphere, the cyclones move west-northwestwards or northwestwards. So if a cyclone is developing on Northwest Pacific, it has to move towards northwest, and hence it comes towards the Southeast Asia, that is Thailand, Vietnam, and southern parts of China. So when it is moving towards that, you will find that this land area is very neck-like structure, very thin, about 100 to 200 kilometers. So while these cyclones move across this landmass, they do not dissipate completely. So remnant of the cyclones emerge into Andaman Sea. As the remnants emerge in Andaman Sea, these are again subjected to favorable conditions like higher sea surface temperature, ocean heat content, lower vertical wind shear, and therefore they intensify further. You'll be happy to know that about 70% of these remnants emerge into the Bay of Bengal. So therefore, the frequency of this carried forward, the cyclones or remnants becoming cyclones are more in the Bay of Bengal. In Arabian Sea, that does not happen. The cyclones which develop over Bay of Bengal, they move across peninsular India and they emerge, but by that time they lost energy and they do not further intensify. There are very rare cases, of course, when the Bay of Bengal cyclone goes into the Arabian Sea. So these are the two important reasons for in situ and although the cyclones moving from Northwest Pacific, which makes Bay of Bengal more prone for the tropical cyclones.
Thank you very much, sir. Thank you for accepting all our questions and answering all them things. So few questions are still left behind because of paucity of time. We have another meeting at online meeting at 12 o'clock. So I think we'll stop here. And it was an excellent lecture, sir. It was brilliant. Rather, all the slides were flooded with data and all these things. So with these few words, I'll request our honorable director to give his presidential remark.
Yeah, I'll just tell one point that if anyone is interested, they can write to me. My address is email address is given, and they can write to me. I will be happy to reply.
So thank you, sir. And thank you, Dr. B.C. Patra. Greetings from National Rice Research Institute to all. Honorable Director General, Indian Meteorological Department, Dr. Mrityunjay Mohapatra, and today's speaker of NRI Foundation Day Lecture 2021. Respected Secretary DR and DG ICAR, Dr. Untitled Mohapatra, whose constant support and guidance made today's program to happen successfully, though he could not join for some preoccupations. Esteemed QRT and RSC chairman and members, DDGs of ICAR, past directors of these institutions, senior officials from ICAR headquarters, esteemed dignitaries, my colleagues from NRI and other institutes on board. It is my great pleasure to listen to such a knowledge-packed deliberation on weather forecast for agriculture as a Platinum Jubilee Foundation Day lecture on this penultimate day of 76th Foundation Day and final day of 75 years of glorious journey of National Rice Research Institute dedicated to the service to the nation and rice science. Sir, this morning you started with a nowcast and we received a downpour during your deliberation at Cuttack. And at the same time, you also relieved us to declare that the S2S forecast ensures most likely normal monsoon this year, more or less across the country. As we know, weather forecast has extreme relevance to agriculture, particularly in India with vast rain-fed ecology under the cultivation. The relevance has increased manifold in recent years due to climate change, induced unpredictable weather aberrations, and frequent extreme events. So weather forecasting, both short, medium, and long range, can help the farmers' business decision-making very easy. Forecasts can help them plan for the many day-to-day decisions also. These decisions include crop irrigation, time to fertilizer, application and plant protection measures, decide what days are suitable for working in the field, and so on. So weather forecast-based decisions that farmers make would likely to result in a profitable crop harvest. Each range of weather forecast plays an important role in farm operations and planning of agricultural activities. It is also very good news received from you, sir, regarding the system of forewarning of extreme events, particularly downpour, which is going to be in operation this year soon. This will provide additional assistance to the farming community in terms of saving the crops or harvested crops and livestock to a great extent. So today's deliberation strengthened our insight into this area of science. This institute is also dedicatedly engaged in developing weather-smart rice production technologies and dissemination of fortnightly agronomic advisories for concerned districts through its KVKs under the DAMU project of IMD. The additional perception gained today will certainly help us to refine our research program to make it more climate smart. So with this, I would like to conclude my remarks. So thank you, sir, Dr. Mrityunjay Mohapatra. I also extend our thanks to our Honorable DG, Dr. Untitled Mohapatra, Thank you all, dignitaries and delegates, ladies and gentlemen. Thank you all and stay safe. Thank you.
Oh, thank you, sir, for your remarks. And now it's time for a formal vote of thanks, which will be given by Dr. Shrutapa Sharkar, who is a scientist at NRI. Shrutapa Sharkar, madam, please.
Thank you, sir. Thank you, Dr. Kutu. Am I audible?
Yes, yes, go ahead.
Thank you, sir. Thank you, sir. Thank you, Dr. Kutu. Sir, I feel really privileged to present the vote of thanks on today's occasion. I, on behalf of my entire National Rice Research Institute fraternity, extend my heartfelt and sincere thanks to our today's speaker, Dr. Mrityunjay Mohapatra, Director General, India Meteorological Department, for accepting our invitation to present today's lecture for the Platinum Jubilee Lecture Series. Thank you, sir. You took out time from your busy schedule to address us on this occasion. We feel really honored to have you for this. Sir, you were here at Odisha during the super cyclone of 1999, when your hands were bound as we had only the 24 hours prediction technology available. You took this up as a challenge and became one of the pillars of the modernization of India's weather prediction system. The super cyclone killed 15,000 people, but the modern weather prediction system could save millions of lives during Filin, Hudhud, Bandhan, and we personally experienced the precision of your prediction and its significance during Phoni and Amphan. We extend our sincere thanks for revolutionizing the forecasting system in our country. You are the Bhumiputra, Satya Sai, and Bharat Gaurav who touches every life every day in the country. We are also encouraged to see you and your team undertaking sincere efforts to support the agriculture sector. We, being one of the major clients of your information, thank you for your continuous efforts to increase the precision further and make it more useful for all the stakeholders in the sector of agriculture. Thank you, sir, for joining us on this occasion. After this, I would like to thank our director, sir, Dr. Dipankar Maiti, for his continuous encouragement and support to arrange for the excellent lecture series by eminent personalities from diverse fields throughout the past month to commemorate the Platinum Jubilee Foundation Day. I would like to thank the heads of the divisions in charge of research stations, KVKs of National Rice Research Institute, dignitaries from ICR, directors of various institutes who joined us for this lecture. Then I would like to thank and congratulate Dr. B.C. Patra, Chairman of the Committee for the Platinum Jubilee Lecture Series, and the other co-members of the committee, Dr. Kutubuddin Ali Mullah, Dr. Ranjan, for their sincere efforts and cooperation for the grand success of the lecture series. Then I would like to thank Mr. Santosh Ji for his support to provide such a beautiful platform to link more than 150 participants. Nearly we touched 160 participants together for this highly informative and thought-provoking lecture. I extend my sincere thanks to all the audience for joining in such a large number and showing their great interest on the subject, patient listening to the speaker, and active participation during the question-answer session to make the occasion more lively. I would like to thank one and all who have been associated directly or indirectly for making this a grand success. Thank you, one and all. Namaste, Jai Hind.
Namaste.
Thank you, Dr. Shrutapa.
Over to you, sir.
So, shall we call it a day, sir? Thank you very much.
Yes. Thank you very much, myself.
Thank you, sir. Thank you very much.
Sir, thank you very much, sir.
Thank you.
We leave the meeting, sir.
Yes.
Yes, I'm there.
Thank you, sir.